In this video, we will see how to solve a problem which makes use of the sliding window, which is an array optimization technique. The problem statement is to find the maximum of all subarrays of size scale. We are given an array of integers and we are also given an integer k. The problem is we have to find that subarray of size k that has the maximum sum. So for example, let's look at this input array 2, 1, 5, 1, 3, 2 and let the window size be 3. So here we have to find the sum of 2, 1, 5, then the sum of 1, 5, 1, then 5, 1, 3, 1, 3, 2, and we have to say finally what is the maximum sum in any subarray of size k. So here the output is 9 because when we add 5 and 3 we get 9. This is best solved using a technique called the sliding window technique. Let this be an input array and let our k be equal to 3. The sliding window technique works as follows. First we take a window of size 3 in the array, that is 5, 7 and 65. We perform some operation. Then we move it to the next 3 elements, that is we slide by 1 and again have a window of size 3. In the next step we slide again by 1 and have a window of size 3. This is called as a sliding window technique and it is a array optimization technique because it is a known technique to reduce the time complexity. Finding the maximum subarray in an array is equivalent to finding the maximum element in an array. The way we solve both are actually the same. For example, if we have to find the maximum element in this array, what will we do? We will first check 5 and 7 and out of that 7 is larger and so we will say that the maximum element is 7 and we will fix a max as 7. Then we will compare 7 and 65 and we will see that 65 is bigger and so we will now say that the max element is 65. Subsequently, we will check 65 and 8, then we will check 65 and 7. In all the cases, 65 is still the maximum element and so we will keep saying that the maximum element is 65. And finally, we will check 65 and 99. Now 99 will be bigger and so we will say that the maximum element is 99. This is the usual logic we use. The problem statement that we have is to find the maximum subarray. The way we are going to solve it is similar to solving a problem in which we have to find the maximum element in an array. The same logic we will use to find the subarray which has the maximum sum. The subscript of the array is from 0 to 8 and we are going to solve this problem using Python. So initially we will see that the array is from 5, 7 and 65 because our k is equal to 3. And we will say that the maximum sum is the sum of the elements in this window. This is the initial step that we perform. When we perform it, let's also look at what will be our time complexity. The time complexity is we are going to just add 3 elements 5, 7 and 65. So the time complexity is dependent upon the window size. So the time complexity will be big O of k. In the next step, I have to now slide the window by 1 and again I have to calculate the maximum sum. To do this, I have a loop starting from I is equal to k up to I is equal to n minus 1. Here, in this case, I again calculate the window sum. But note the difference here. I need not calculate the sum of 7 plus 65 plus 8x plus 5. I just have to drop one value 5 and I have to add one value which is 8. I minus k is nothing but 3 minus 3 which is 0. So we say that it is ARR of I minus k that we are dropping. And similarly, we are adding A of I, and we know that the current value of I is k. Let us see the code in Python. We define a function called as maxSum subarray. It takes two arguments. One is the array itself and the subarray size that we are calculating. Initially, we initialize the length of the array as n. Before processing, we have to check that the size of the subarray is less than the size of the entire array. Else we have to return that there are not enough elements. Initial step is to compute the sum of the first window, and we have already seen that the time complexity is big O of k, and this we keep it as maxsum. Next, we slide the window for I in range k comma n, which means it will go from k to n minus 1, and this one single loop. So this entire loop runs big O of n minus k times. To calculate the window sum, it is now in the order of big O of 1 because we are only adding an element and dropping an element. And then we are trying to find the maximum between these two, which is again a big O of 1. So now if you see, this is a big O of k plus this is a big O of n minus k. So the final time complexity becomes big O of k plus big O of n minus k, which is much less than big O of. The various test cases are, let's change the size of the window and check. Similarly, we have to check the edge case, that is the case in which the last few elements are actually going to form the final answer. Similarly, we have to check the case wherein we do not have a valid input. Here the number of elements in the array is 2, but the size of the window is 3. So in which case it has to return that it is an invalid case. And if we run and see, we see that it passes all the different test cases.